10 after? I have it as 10 after. Okay, so today we're going to do a little more about the internal structure of arguments, making just one basic distinction between premises that entail their conclusion dependently and independently. I'll talk about that in just a sec. To start off, why don't we review some of the questions that were sort of like on the handout that I gave you last time, but that we didn't talk about. So just to quickly review the notions of validity and soundness. So recall that validity is the strongest form of logical strength. So logical strength is the degree to which a premise should raise your credence for the conclusion, should make you more likely to believe or makes it more rational to believe the conclusion. So there's a kind of continuum between from offering no support to offering little support to making it very likely to making it absolutely certain. And so validity is the kind of endpoint at the certainty side of that, where you say, if these premises are true, you should be certain that the conclusion is also true. And then soundness is that validity plus your confidence that the premises are true, right? So that's validity, that's soundness. So, yeah, question? The question is, did I say that an argument can be sound but not valid? I hope I didn't say that, because that would be wrong. The only case in which an argument is sound is when it's also valid. Right, so I asked the question on the quiz, I asked, is this thing sound but invalid? And if you pick that, you got it wrong because that's not a thing that can happen. So keep that in mind. All right, so let's look at these. There's 4 of them, and we'll just give me your best impression. Are these valid? Are they sound? So this one, Justin Trudeau is the Prime Minister of Canada. The Prime Minister is necessarily a trustworthy person. Therefore, Justin Trudeau is a trustworthy person. Is that valid? At least start from validity. Is it valid? Yeah, so if those 2 first things are true, obviously the conclusion is the stuff that comes after the therefore. That's your hint. So the first 2 sentences are premises. If those were true, can you imagine a world in which the first 2 things are true, but the third thing is false? I don't think you should be able to imagine such a thing, if the first 2 things are true. Okay, anybody worried about that? You see how that's a valid argument, so that like, you just can't have it be the case that this guy is the Prime Minister and necessarily the Prime Minister is trustworthy, and then have it come out that this guy doesn't happen to be trustworthy, right? Okay, now is it sound? That is, are these premises true, all true? Yeah. Good, the second premise is the problem here. So is the Prime Minister likely to be a trustworthy person? We could have a serious debate about that, right? We could actually talk about whether Prime Ministers in general have been trustworthy people. But there's this really strong word in there, necessarily. Right? That's a way stronger claim than you want to make. So I'll just point out what necessary means here. So for a philosopher, to say something is necessary is to say that it's true in all possible worlds. So any consistent set of facts that could be possible, it has to be true in all of them. So there's no possible, what you're claiming if you say the Prime Minister is necessarily trustworthy, is you're claiming that there's no possible universe in the infinity of possible universes where we get a crummy Prime Minister. And I hope you can imagine that. Possibly you think that's the situation we're in right now. So certainly, like we could have a discussion about whether Justin Trudeau is a trustworthy guy, but even if you believe that he is, that doesn't mean that he's necessarily, or whoever is the Prime Minister is necessarily trustworthy, right? So, here are a couple of necessary truths. If it's raining, then necessarily there's water falling from the sky. Like that's necessary because one thing is just the same thing as the other, right? Water falling from the sky just is raining. So there's no consistent possible world where you have one happening and not the other, right? And similarly, squares have 4 sides necessarily. Again, if you know what the word square means, you know that it's got 4 sides. And if you don't use it in that way, you're just using the word wrong, right? So there's no possible, you cannot consistently imagine a universe in which what we mean by squares don't have 4 sides. You can certainly imagine using that word differently, but given what people mean by that word, there's no 3-sided squares. There's just none in no possible universe. So that's necessarily, or necessity, is an extremely strong claim, and it's certainly not true of the relation between prime ministers and trustworthiness. Okay? Okay, So we'll go faster through the next ones. But water boils at 100 Celsius. You shouldn't drink things that are more than 100 Celsius. Therefore, you should drink water. Is it valid? I don't think so. I don't think so. I don't think this is valid because it's so, like, because the first two things are true, right? Well, oh, sorry. No. All of these things are true. Okay, so all of these things are true, right? Water boils at 100 C, at sea level. You shouldn't drink things that are more than 100 C because you'll die. And you should drink water. All three of those things are true, but there's not an inferential relation between the first two and the third, right? That's what makes this a valid or invalid argument. So water boils at 100 C. You shouldn't drink things that are more than 100 C. Therefore, you should drink water. Is not like those first two things aren't a reason to believe the third thing. They're just kind of unrelated ideas, yeah? Despite the fact that all three are true. Right? So this is, again, a valid argument is one where the first two things should make you believe the third thing, not just that you can imagine a consistent world in which all of them are true. Is that clear? So suppose that we were formed of a profoundly different chemistry, like astrobiologists talk about all the different sort of ways that we could have been chemically speaking if there's other alternate, like, basic solvents for life. So like maybe liquid methane could make a solvent for life. In that case, we would never drink water. We would drink this other solvent. And it would still be true that water boils at 100 C, and you shouldn't drink things that are more than 100 C, right? If we were based in a profoundly different sort of chemistry of life, something like that. So there's a possible world. Actually, it could be true of like aliens in another galaxy where water is poisonous to them. Nonetheless, it still boils at that degree, and you shouldn't drink things that are hotter than that. Right? Okay. So, by the way, of course, it's invalid, and therefore we don't even have to ask whether the things are true to know that it's unsound, right? Because if it's invalid, even if everything is true, it's still unsound. Okay. If Socrates wears sandals, then he's mortal. Socrates wears sandals, therefore he's mortal. Is it valid, at least? It is valid. It is valid. This is a classic, this is modus ponens again. This is just if x then y, x therefore y, always valid. So this is always going to be, if it's exactly in this form, it's always a valid argument structure. Now, is it sound? Are these things true? I don't really understand the connection between, I wrote this, so I should understand, but I don't. If Socrates wears sandals, then he is mortal. Those things don't really seem all that connected, so I'm not gung-ho for that conditional as being true, right? So if there's some reasonable connection between wearing sandals and being mortal, but like if there was somebody who was immortal, they could wear sandals, right? Or you could put sandals on a statue or something like that. I don't know. Like maybe Socrates is a statue, not a man. I don't know. So this is dubious. I find this to be dubious as a sound argument, but it's clearly a valid argument. So what we need to know is, where do you get this first premise? Why do you think that's true? So there's a question about the acceptability of one of the premises that makes it questionable whether it's sound. But we know for sure, even not knowing that it's valid. Yeah? All restaurants serve alcohol. Every place that serves alcohol also sells donuts. Therefore, all restaurants serve donuts. Valid? Valid. Sound? Obviously not. Okay, good, you get it. All right, how about this one? This one was not on the thing, but how about this? All rivers have banks, banks have vaults, therefore all rivers have vaults. It is a trick question. Yeah. Well, okay, how is it invalid?
Because the word bank, you're using it in 2 different meanings.
Good. So, good. I think you can also read this as unsound. So in the case that you say, like, look, you're just using banks twice in 2 different ways. So if you say, like, all rivers have banks 1, banks 2 have vaults, where banks 1 is like the side of a river and banks 2 is a building where you get money, then it's clearly invalid because all rivers having banks 1 doesn't connect up with banks 2. Is there a way to have this be a valid argument but unsound? Yeah.
If you say that all rivers do have banks 1,
right.
then
Exactly, exactly. So you just say, if instead of saying, no, we're using the same word for two different ideas, you say, no, these are the same ideas, that just makes one of the premises false. Right? It's clearly false that all rivers have banks in the same way that all banks have vaults. Okay? So in this case, it depends what the error is, right? Whether it's a problem with validity or a problem with soundness. Okay? So one of the reasons why you might want to have the kind of formal tools that we'll be developing from here on in is to pick apart this kind of question. Say, like, okay, what exactly is the problem with this argument? And to put your finger on it in a more precise way. Okay, so that's what we'll do for the rest of the class. Unless there's any questions about the basic ideas of validity and soundness. We'll come back to validity and soundness over and over again because they really are like teasing apart like just thinking every part of an argument is true from thinking it's a valid argument is really the point of this whole course. Like it's really the most fundamental skill that you'll be learning. And it is harder than it, I mean, should be fairly straightforward. It's harder than it looks when you get into complex natural language arguments. But, okay, good. Okay, so let's do some argument structure stuff. So you're familiar with this picture of just like a premise leading to a conclusion. This is the most basic argument diagram that we're going to look at. Like this is the most simple structure that you could possibly have of just like one idea being offered as a reason for another idea. And this class we're kind of just going beyond that to like how can arguments have several premises where the premises are related in various ways. So don't panic. This isn't on the test. But I wanted to show you what a really rigorous deductive argument looks like. So this is from symbolic logic. And I think this will be helpful for understanding what the argument diagrams are kind of for. So in math and logic and computer science, they do what's called formal proofs. This is the thing that I asked you about, like, have you ever heard of this thing? So about 40% of you said you've never heard of formal proofs before. So here's a formal proof. This is what one looks like. And what they're trying to prove here is the falseness of W. So that little tilde W thing that says not W. And that's the conclusion that this whole thing is trying to prove. And the question is, can you prove that using these as premises? Right? So, and this is the proof, right? This is the argument given that given if Z, then if X, then not W, and if not Z, then not X, and X as premises, you can prove in these just a few short steps that, in fact, not W must be true. So we say show not W, and then each line comes from somewhere, right? That's the basic idea of a formal proof, that at every single step, you say exactly what justifies that step. And there's a very constrained and finite number of rules that you can appeal to. So you can appeal to the axioms of logic. So there's certain like basic postulates of logic that you can always use. You can use the premises that you're given. So these are the things up here. So given these premises and the axioms of logic and a few, maybe like this is just basic sentential logic. There's maybe a dozen rules that you're allowed to apply at any given step. And every single step has a rule associated with it. So this one, you get X just from premise 3. So this is premise 3. That gives you X. So, and then from line 2, so this is line 2, double negation, you get not X. So double negation just says if you have X, you can have not X. And if you have not X, you can have X. So that's a valid inference rule. And you say this one from premise 2, and you get not Z from 3, 4 modus tollens. So this says if not Z, then not X. That's from premise 2. And this one says not X. And then you can say if not X, then not Z, right? Okay, so the point is just that, so what I want you to notice here is, so understand that each of these steps is justified by either one of the premises or a manipulation of one of the premises by one of these very, like, these logical rules that everybody agrees work perfectly, okay? And nothing, you don't get to help yourself to anything except what's been introduced as a premise or what's been derived from one of the premises. Okay, and that's what makes it a rigorous logical proof. So you should look at this, if you sort of know how to read it, and go like, wow, that is the most convincing possible argument for that not W follows from these three things that you could possibly want. There's no doubt whatsoever, right? It's completely truth preserving in the sense that if the premises are true, the conclusion is guaranteed. There's no better guarantee that you're going to get all day, I promise you. This is like as rigorous as it gets. Now, we're not doing this. We're doing something sort of structurally analogous to this, though, however. So the point of an argument diagram like this is to show what you're using. So give me this, and then I'm going to use it to show that, right? And you're making explicit what the relations between the ideas are. Now, we're not citing the rules here. So we're just sticking in an arrow and saying there's a relation between these. There's an inferential relation between these. So I'm not going to ask you to say, well, this is double negation, and this is modus tollens, and this is modus ponens. It's helpful, but today, the only thing I'm going to show you is the difference between two independent reasons for a conclusion and two dependent reasons for a conclusion. And you can actually see that difference in this proof. So the double negation step, right? So not X is perfectly good evidence all by itself for X, right? So from not X, you have every reason in the world to believe X. That's a case where you have one premise as an independent reason for another premise. Now, there's other points in this where there's dependent reasons for the other premise. So we got on these lines, so 6, 7 modus ponens. So line 6 says Z, and line 7 says if Z, then if X, then not W. So given those two, both of them together gives you the consequent of that, which is line 8, X, then not W. Right? So you need both those things to be true. It's just the nature of the rule modus ponens that you need the two statements to plug into it. Unlike double negation, you only need one statement to plug in to have the rule apply. Modus ponens, modus tollens, and a few other logical rules, they just need two things, or else you can't derive what you're looking for. Okay, so that's structurally similar to what I'm going to talk about today, which is this. So the difference between dependent and independent reasons. So these are two ways that premises could be related to a conclusion. They could either be each independently a reason to believe the conclusion. So the relation between the premise and the conclusion doesn't depend on the other premise being true, or they could be dependently related. So both need to be true at the same time for either to be a reason to believe the conclusion. Okay, that's all abstract, but we'll do it in kind of cases right now. So let's start with independent reasons it's not the case that, and I want to try to be crystal clear here, that we're not saying that these are, either of them are sufficient to show you the conclusion. Or we're also not saying that either of them has to be enough to believe the conclusion. It's just about the relation between the premises. Let's do this. Okay, so independent reasons for the conclusion, you are a bad roommate. 1, you don't clean your dishes, and 2, you haven't paid your rent. Okay, so I take it that either one of these is enough, is a reason or could be a reason to believe the conclusion. And the other one doesn't have to be true for the first one to be a reason. So, suppose you are paying your rent, but you never clean the dishes. Now, that's a reason. It should raise the probability in your mind of the conclusion that you're a bad roommate. I hope this is news to none of you. Okay, so similarly, even if you do clean the dishes and you're not paying rent, that would be the fact that you're not paying rent is a reason to raise the probability in your mind that you're a bad roommate. Now, maybe neither of those together is even enough to show the conclusion. Like maybe you're just such a sweet person and you're in a terrible situation where you can't manage to do either of those things, but nonetheless you bring enough light and joy to your home that you're still a good roommate. It's possible, right? So neither of these are enough to guarantee the truth of the conclusion. We're not dealing with, this is clearly not a deductive argument, right? This is clearly the other kind where the truth of the conclusion, the truth of the premises doesn't guarantee the conclusion, it just sort of raises its likelihood. But nonetheless, these are bits of evidence that you might consider that might raise your belief in the conclusion. And they don't depend on each other for that relation. So it's about the logical structure of the premise-conclusion relationship. Yeah? Okay. Here's another one. The cat is sick is the conclusion. 2 independent reasons might be that she hasn't eaten her food and that she won't play with her toys. Similarly, like either one of those would be a piece of evidence that the cat is sick. And together, they make better evidence than either one independently, right? So it's not that you get nothing by adding the other one. So it's not the case that like one on its own would be just as good evidence as both together. You know, they both contribute to raising the likelihood of the conclusion, but they do so independently of each other. Now, this contrasts with the dependent reasons relation. So where if only one of them is true, the other provides no evidence for the truth of the conclusion. Now, classic modus ponens, all men are mortal, Socrates is a man, therefore Socrates is mortal. So this is like the classic dependent argument structure. And we saw in the formal proof with modus ponens, which is this is an example of, you need 2 things to plug into the rule, right? Just the fact that all men are mortal does not entail that Socrates is mortal. Just the fact that Socrates is a man, if you don't already know that all men are mortal, would not entail that Socrates is mortal. Another example. Those who hesitate are lost. You hesitated, therefore you are lost. So, just the fact that those who hesitate are lost does not by itself mean that you're lost. Maybe you didn't hesitate. Just the fact that you hesitated also doesn't mean that you're lost, especially if you don't believe this hokey like saying, which says those who hesitate are lost. Right? Maybe you don't think that's true. I think people tend to believe things just because they're old sayings, but lots of people hesitate and are not lost. So the only way either of those gives you evidence for the conclusion is if they're both true together. Right? The dependent reasons relation. Yeah? Okay. So what I recommend here as a kind of heuristic, or as a rule of spotting these things, is what there's a great teacher of critical reasoning, Jonah Warren, who calls the puzzle piece method. So the puzzle piece method goes like this. You say, look, what you're looking for is some kind of overlap between the 2 premises. To tell if premises are dependent, there should be some overlap between them, some like common part that drops out in the conclusion. So like you can see the puzzle pieces, like the middle part of a puzzle piece doesn't disappear when you put them together, but they're kind of like melded together. So those who hesitate are lost. You hesitated. The part that's common is, of course, hesitation. And then in the conclusion, hesitation drops out. So you just get you are lost. Right? So the method here is, if you're looking at 2 premises and you can fit them together in this puzzle piece relation where there's an overlap between the 2 premises, and then that overlap drops out in the conclusion, then that's a really good sign that they are dependent premises. Right? And you'll see these in categorical statements. So you can see in the form of like all x's are y. And you can also see these in, so this is a categorical statement. And you can also see this in conditional statements. If x, then y. Right? And then if you use these, so these are both common parts, like 1/2 of a dependent pair of premises. And then here you'd say all x's are y, this is x. And then the common part, and then so therefore this is y. So the common part is the x bit, right? And then the x bit drops out and leaves only the y bit. And you can do the exact same thing, I think you can see for the conditional. Yeah. Another one, all dogs are friendly, Gonzo is dog, therefore Gonzo is friendly. So what's the common part that drops out here? Yeah, it's the dogginess. The dogginess is shared in both premises, and then it doesn't get mentioned in the conclusion. You just sort of like squish them together, and the common part is eliminated. Okay, so that's a kind of like quick and easy way of thinking about dependent and independent reasons. Now, in real-world contexts, it's rare that people speak in this clunky, repetitive way where they repeat themselves exactly. Sometimes it's rephrased, and you have to hunt. You have to hunt for a way to get it into this form. But if you get the form, you'll be able to see it. You know, like if it says, all dogs are friendly, Gonzo is a terrier, therefore Gonzo is friendly, you could kind of like just quickly in your head go, oh yeah, that fits. Terrier is another word for dog, so puzzle piece, dependent relation. Okay. So that's it. I mean, that's the basic idea that I wanted to show you today. We'll do exercises on Thursday where you practice this, but like that's the main syntax for the whole course. Like this is the main technical skill that you got to get in this first half of the course, and then we'll just have this. I mean, you're going to be super sick of this. You're going to be, if you're feeling like this is slow and boring already, you're just going to be so bored of this stuff. But it's good for you. It's good for your ability. If you practice this stuff over and over again, it will make you better at seeing the structure of arguments. And that's what we're trying to do, is kind of represent the formal structure of the argument without having to go the full deductive logic. So the deductive logic version of this, these arrows are all specific rules of inference. And there's a very limited set, and you have to get the premises into just the right form to make the rule apply. We're kind of accepting that, you know, there's a dozen rules in propositional logic, there's maybe a dozen more in the next step of quantifier logic, and then there's hundreds and hundreds in the various different forms of logic. But in informal reasoning, there's probably like an unlimited number of relations that you could have here. So we're kind of just saying, okay, we're not going to try to specify exactly what this relation is in the diagram. Just say that they're related and what is related to what. And that gives you enough of a handle on how the argument is structured that you can then kind of look at it and say, okay, now does this relation make sense? And hopefully what this will do is allow you to say more precisely which part of an argument isn't working and why. So is it that you believe the premise? Is it that you don't believe the relation between the premise and the conclusion? You can really kind of spread it out into parts and say, okay, this whole part of the argument is fine, it's just falling down here. It's a very valuable skill if you're trying to like convince somebody of something, because you want to agree with them as much as humanly possible. You want to agree, if you're trying to argue with somebody, you want to agree with as many parts of what they're saying as you can, because that like reduces the conflict and it increases the common ground on which you can draw. So that's the point of this. All right, let's just do a couple of examples quickly. We'll do more examples on Thursday, but let's just do a few now. So are these two premises dependent or independent reasons to believe the conclusion? Hunting rhinos is morally wrong. Hunting rhinos is too expensive. We should not going to hunt rhinos. Fill in something that makes sense for the conclusion there. Okay, so if there's any big fans of rhino hunting in the room, I'm not trying to say that these premises are true. I'm just saying, are they dependent or independent reasons for believing the conclusion? Sorry? So are these dependent or independent? Independent, right? If it was morally wrong to hunt rhinos, but you had plenty of cash, you probably still shouldn't do it. If it wasn't morally wrong, if the country was just overrun by rhinos and they were a pest, but it was too expensive, then you still shouldn't do it, right? Good, so independent. Poor diet can lead to stomach trouble. You have a poor diet, therefore you're at risk of stomach trouble. I don't know if that was a mix or just people saying it at the right time. These are dependent reasons. You can apply the puzzle piece test. Poor diet can lead to stomach trouble. You have a poor diet. The part that's common is poor diet, and the part that remains is you have a risk of stomach trouble. Right? Clear? Good. I see a light on in the window next door. I can hear music coming through the wall. Therefore, my neighbors are home. I hear independent, which is, I believe, the correct answer here, right? Either one of those would be at least some evidence. Neither one is conclusive evidence, and even the combination of them isn't conclusive evidence, but either one, independently of the other, would act as at least some evidence. Yeah. Good. Okay, so really quickly, I just want to re-look at this thing. recall this thing from the exercises last class. We'll kind of just do this. I want to give you a tiny preview. So what I just showed you is basically all of the kind of syntax that I'll make you learn for the course. And we're just going to do it building up on like complexity. So what I propose to do is just like talk through this and say, all right, what does the argument diagram for this look like, right? Okay, so advertising is not manipulative, as many people think. 75% of people polled thought the main point of advertising is to trick people. That simply isn't true. All right, so we talked through this last time, and I think we came to something like this as the main structure. So the conclusion being advertising is not manipulative. There was some debate about that, but let's go with that for this. So the main thing advertising does is provide us with information. Providing information isn't a form of manipulation. Another function of advertising is to entertain. Entertainment isn't manipulation. Also, I think it's probably worth pointing out, just quickly, somebody pointed out that there's kind of a mini, I cut out the 75% of people polled thought the main point of advertising thing as not a premise in this argument, because it's kind of arguing for something that isn't the conclusion, right? So, but somebody pointed out this, you could regard this as a kind of a mini side argument in the argument. So advertising is not manipulative as many people think. So that could be the conclusion of a mini like embedded argument that goes, advertising not manipulative. Many people think advertising is not manipulative. And here's the evidence, 75% of people polled thought, right? So you could read that part as like a little embedded argument, but for the purposes of analyzing it, because it's just explaining the conclusion rather than arguing for it, I would cut it out as not a premise. Right? So what it's doing is giving context and background, also kind of giving it a little argument, but not an argument for the main conclusion we're talking about. Okay, so the conclusion, advertising is not manipulative, right? And what do you think, okay, so given P1, P2, P3, P4, what do you think the structure of this argument is? Right? Yeah.
Premise 1 and 2 are dependent.
Good. The conclusion, so P1, P2 are dependently related to the conclusion.
And then P3 and P4 are also dependent. That also leads to the
Exactly. That is exactly how I would break that down. Right? Like so. See, so it's exactly what I just showed you, dependent and independent reasons, but kind of iterated a little. So there's two sets of dependent premises that are each independent reasons for the conclusion. Right? And then you can have things leading to those premises and things leading to those premises. You can have multiple independent premises. You could have more than two things in a dependent relation. So if you say, like X is taller than Y is taller than Z, then you have like three things and you need evidence for all of them. Okay, so this is basically what we're gonna do for most of the rest of the first half of this semester. We're gonna do this in more detail and this with less clearly, like I wrote this argument specifically to be easy to analyze. I also made up the 75% thing, so don't quote people on it. Like, that's not a real statistic, I made that up. So this was an argument that was specifically designed to be easy to analyze so that you could see how this is supposed to work. We'll do more that are sort of straightforward to analyze in this way, and on the test, I'll give you something that's really designed to be, this is actually a test question from last semester's midterm, so this is designed to be straightforward for you to get, and then the goal will be to move you from this, so we'll spend a couple more weeks kind of getting a mastery of this, and then in the second half, we're going to shift to harder to parse versions, or harder to parse arguments where the structure is more ambiguous, it's less obvious what's meant to be there, and so on. All right? So that's the plan. All right, I think that's it. So next time we'll do more argument mapping stuff. That was quick, sorry.